The overall goal of the following experiment is to perform in situ measurements of the local physical properties of a bacterial biofilm at the micrometric scale. To do this, magnetic particles are introduced into a growing biofilm to serve as probes that can be remotely actuated without disturbing the structural properties of the biofilm. Dedicated magnetic tweezers are then used to exert a defined force on each particle embedded in the biofilm. The particle displacement induced by the magnetic pulling is monitored using video microscopy to derive the local viscoelastic parameters and provide the 3D spatial distribution of the mechanical properties of the biofilm. Results are obtained that show the mechanical heterogeneity of the E. coli biofilm and gives clues as to which biofilm components support the biofilm physical properties.
So the main advantage of this technique over existing methods like microscopic rheology or whole biofilm annotation is that it reports the spatial distribution of the mechanical properties in situ without disturbing the original structure of the material.
To prepare magnetic particles for this protocol, vortex a stock vial of 2.8 micrometer particles to resuspend them. Then, transfer 10 microliters to a microcentrifuge tube. Then, to wash the particles, add 190 microliters of minimum medium and swirl the tube. Place it on a magnetic sample rack, wait for the formation of a pellet, and aspirate.